All right, let's do this, huh? The topic for today, more circle facts. Yes, to add to that long book of facts you already have. But these are really concerning chords today and arcs. All right, some circle facts about arcs of a circle and chords of a circle. So the first thing I need you guys to do here, in my first circle, instead of just reading off the theorem to you, draw me a central angle, please. Draw me a central angle, label it with some letters. All right, make a central angle. And if you don't know what to make, then we got bigger problems than today. And then I'd like you to make, in the same circle, a second central angle that looks congruent to your first one. So anywhere else, go ahead and make a second central angle that looks congruent to your first one. I would like it to be congruent. And tell me they're congruent by putting those arc marks on those central angles. And here's your first circle fact of today. What I have up here is not what I want you to start writing in your reasons column when we get to it. So underneath, I'm going to have you what I actually want you to write. So here's our first circle theorem here today. Congruent central angles imply, there's our arrow, remember that bad boy? So if the central angles are congruent, so are the arcs. How do you mark arcs congruent? Same way we mark segments, with hash marks. All right, so congruent central angles imply congruent arcs. In the same circle, right? In the same circle. And number two is just the reverse. If I give you the arcs are congruent, so if I started off by saying the arcs were congruent, that means the central angles are congruent. All right. And we're still not done with this one. Sorry. Any questions with what that means? If the central angles are equal, the arcs across are equal. If the arcs are equal, so are the central angles. I'm not going to do a new box for this one here, but just realize that you could substitute a word in for the word central. What other type of angle have we talked about inside the circle? Minor angles. Minor. Arc. Headlock. Which word can I substitute in for central? Inscribed. Okay, I don't need to do a whole new presentation on this, all right? But you could, instead of anywhere you see the word central, I could substitute inscribed. All right, so substitute in inscribed for central angle. All right. So just heads up there. All right, heads up. Same exact fact, but now use inscribed instead of central. Minor angle. It is your bad. We're all good? Next up. Draw me a chord, please. In this next circle, draw me a chord. Label it. And then draw me a second chord that looks congruent to your first one. And heck, let's not make it look like it. Let's mark it like it is. And here you go. If you have congruent chords, that means you have congruent arcs. So if A, B, and CD are equal, so are the arcs A, B, and CD. And then the reverse, just so you know, we got it there. If I initially told you the arcs were equal, that means the chords are congruent. All right. And again, what I'm having you write down is what do I want in the reasons column. I don't need this word for word like I have written there. Questions before we get to the final two? I'll be honest here. This next one here probably won't be used in proofs much, but definitely in some algebra questions, and you don't have to do a darn thing here. Notice how chord D, E, and B, C are both how many units away from A? Just read the number. 8 units away. So if you have two chords the same distance, aka equidistant from the center, those chords are congruent. Okay, two chords equidistant from the center are congruent to each other. All good? I just need to know that they're the same distance from the center. If they are, they're congruent. Anything there? Not much else. I know I kind of glazed over that, but there isn't anything else. Yes, and then here you go. The final one today is probably the one we'll use the most. Draw me a diameter. Draw a diameter in there. Then draw a chord that is perpendicular to that diameter. Draw in a chord that is perpendicular to that diameter, please. And what are you going to put on that chord and diameter where they meet so you show me they're perpendicular? What's going to go on here too? That says they are perpendicular. A right angle, yes. If we have this, a chord perpendicular to a diameter, the chord gets bisected. There's another vocab word from the past, right? The chord gets bisected. So can you add a little bit extra markings now that you know that theorem? If a chord is perpendicular to a diameter, the chord gets bisected. Not the diameter, the chord gets bisected. And I want to stop here because there's different versions you'll see of this diagram. It is very rare that you'll see a full diameter drawn in. Very rare. Instead, you might see this. Fact is still true. Fact is still true. As long as it's part of a diameter, it still works. Heck, guys, you may even see this. Still true. As long as it's coming from the center or going through the center, it's part of a diameter and fits into this fact. So it's going to be rare that you see a full diameter drawn in. It might be a partial diameter, still good enough. All good. Before we tackle some algebra problems. Here we go. Find x, and then you're going to tell me the circle fact that you used. All right away. Is there anything you could tell me about my diagram number 1? Anything that is true about this diagram based on something we have talked about already? Anything you know is true based on something we've talked about today? 9, anything you think is true there?
The part of a diameter bisects the chord.
So the chord is being cut up into a length of 4 and 4. Everyone see that? And now do you know what I mean by a partial diameter? You're just going to see this. But that theorem still applies. So that's 4 and that's 4. Before you guys solve for x, let's write that in the reasons column, what we just used here. A diameter, and sorry, there's no shorthand here. A diameter, I guess this, right? Perpendicular to a chord bisects the chord. And now what are we using to solve for x? Now, what are we using? Oh, 13. Thank you. Yep. X squared plus 4 squared equals 5 squared. Let me know when you hit up x here. Oh, 24? 3. Thank you. all good? Nick, if you fall asleep on me in this class, I will come back there and roundhouse your head off your shoulders. Okay? I'm feeling flexible today. All right, feeling flexible. We can test out the new hip, see how high it can go. All right. Just secretly walk by and just boom, right there, gone. Number 2, what can you tell me about my diagram? There's something else I can. Hey, don't overlook it. You might not see anything there, but don't overlook it. What else can I add to my diagram here? 19? Yeah, everyone always overlooks that. All the radii are congruent. So here's our, in a circle, all radii are congruent. I may just throw out my lower back doing that right now. I may just be crippled right now going down. All radii are congruent. And yeah, we can go Pythag again, or since I'm in an honors class, alternative method, other than doing Pythag here. Oh, you want in now?
45, 45, 90.
It is a 45, 45, 90, right? So I could use my rules. Correct. Either way, it doesn't matter. And I've been fuming since last period because of the directions I left you guys. Nearest 10th in an honors course. I'm going to stick to it. It should be simplest radical form, right, Bridger? That's how we roll in here. Nearest 10th. That's what the frail ones do. All set? Thanks a lot. Nearest 10th when you're ready. Oh, 7 when you're ready. 8.5 looks good. Any questions? Doing all right? Now 3 is I get it. Algebraically, it's a very easy problem to do, but I'm more interested in why, the why part here. So what is true about my give me something that's true about my diagram. 2, something that's true about the diagram.
There's a square. There's 2 right angles.
Okay. Good observation.
Thank you.
There's also the letter C there as well. That's about as right on par with your observation. How about a circle fact that I can apply here? What's that segment labeled 3, 3 and XX called? What are those called? What are these called here?
Chords.
Yep. How far away from the center are they?
Equidistant.
All right. So that means what about those chords?
They're congruent.
Okay. So this chord 6, at least I know that chord 6, right, everyone? Chords, and this is actually the first of 2 we're going to use here. Chords, equidistant from the center are congruent. Oh, that's so much to write. Suck it up. How do I get that? Okay, I get it. I get it, everyone. X is 3. Yep. All right. Nice and easy. But why 3? Why not 2 and 4? Why not 1 and 5? Right? Why 3 and 3? Because of what circle fact? 15? Not here? No? Okay, that's all I needed to know. Thanks. Who is? Oh, yeah. Superstar in his own mind. 21. Hope you heard that on the recording too. Why is that 3, Dan? Why isn't it 4 and 2? Why is it? What circle fact am I using to take 6 and cut it in half?
Oh, the bisect one.
Which is all right. Yeah, it is. Yeah, I don't want you to write the bisect one in the reasons column tomorrow. So I'll start you off. Diameter.
Oh yeah, the diameter that's perpendicular to chord is a bisector.
All right, I like it. Perpendicular to a chord bisects the chord. How's this look, Claire? All right. Good. one more challenge here. These haven't been that challenging, but maybe this one. Finding chord X. Even if you don't know the algebra, at least tell me something you know is true looking at this diagram. What is true looking at this diagram? 19, what's true about the diagram?
The one with like the line with 2 bisects the chord.
Yeah, that chord X is getting bisected. All right, we at least know that's true. So that's at least one theorem we can write. A diameter perpendicular to a chord bisects the chord. So basically, Ellie's telling us, hey, if you can find at least half of it, you can double it and find X. Oof. I don't even know if I could do that, though. Any suggestions here, maybe, to help me around this problem? Somebody in 7th period got it, just saying. Will, are you really, I should just call on Claire here and save you the embarrassment. You gonna do this or what?
Yeah, I'll try. From the center, draw a line to like the edge of the X line.
Okay,
And
you just went through that whole thing, and you could just simply call it what vocabulary term?
draw a radius
Thank you.
to the end of X, because that makes a right triangle. And then you know the radius is 3, so you can do Pythag.
Nice job there, young buck. Good job. Yes, here's what Will was telling us. I already know this radius is 3, meaning if you draw in any other radius, it's also going to be 3. So I could either go this way and say that's 3, and I can do Pythag, or if you didn't see that way, you can draw it the other direction and still make the same right triangle with a radius of 3. Now remember, is this going to get me to X? No, it's going to get me half to X, because I know half of X, because I know that's being bisected. 2 squared plus B squared equals 3 squared. And again, B is only half the chord. Nice job. So just make sure you double that leg value. When you doubled it, 26, let me know when you get it.
Rounded to what?
We have been round to the nearest tenth if necessary.
4.5.
4.5. All right, good. Questions here before we end it. This was all the algebra. All right, let me give you a little taste, little sniff of what's to come tomorrow. Why can't we just wait till tomorrow? Because I like seeing you in misery. That's why. All right, how about that? I like seeing you miserable. All right, let's do this. I'm telling you, B is the midpoint of AC. Prove A congruent to C. We're not going to do that until we know what, though? Triangles are congruent. Yes, so I can do a little CP-CTC action on A and C at the end. All right, help me get the triangles congruent. Start anywhere you want. Give me sides, give me angles. Hey, have a great night, Tyler. Behave.
You too. Thank you.
Yep. I'll try. What is true about my diagram? 2. One thing that's true.
QB, QB.
That guy. All right, there's one pair of sides. What else is true? I think you're going to have to dig deep into some circle facts now. And remember, givens are provided for a reason, not just to read them and forget them, to use them. So what else is true about my diagram? 21?
QA congruent to QC.
Look at you, Dan. Yep. QA congruent to QC. Yeah. Good job, everybody. Why is that fact true? 26. How's Dan know that? How does Dan know that?
In a circle, all react.
Thank you. I love the inner circle part. All right. I think you've done all you can without mentioning the given yet. We go as far as we can. And the midpoint of an arc does the same thing as a midpoint of a segment. So I don't know if anybody is a little, worried that if I call on you, that's not going to be true. Whatever the midpoint does for a segment, it does for an arc. So what else is true here? 10?
Not here.
Of course not. I'm sick. 23.
Arc AB is congruent to arc BC.
There you go. Yep. Arc AB congruent to arc BC, and that's still definition of a midpoint. All right, that gives you a little power now. If the arcs are congruent, there's two ways we could end this proof now. If those arcs are congruent, there's two ways we could go with this. Which way do you want to go, 16?
Can you say
Arcs are congruent. Facts we went over today. If I know the arcs are congruent, that makes what congruent?
the angles?
Which angles?
Angle AQB,
And what type of angles are they?
central.
Okay, so I'll go that way. So you could say because the arcs are congruent, the central angles are equal. Or if you've already written it down, it's correct. If the arcs are congruent, so are the chords. All right, you could do it that way as well. So whatever you're putting here in step 5 could be chords or it could be angles. Angle AQB congruent to angle CQB. And here's the theorem. What did I know? Did I know the angles were congruent or the arcs first? Which one? So that's how I have to start it. Congruent arcs imply, in this case, congruent central angles, or if you guys did chords, you write chords. And then based on the way we did this proof, why are the triangles now congruent? 13? What's my method? Side angle side. If anybody did chords, it would be side, side, side. All right, so make sure you put the correct one down based on if you did chords or central angles. So angle or triangle AQB is congruent to triangle CQB. Side angle side, and then you guys know the deal, CPCTC. So that's just a little taste of what you're running into tomorrow. I didn't put any proofs on tonight's assignment, which you're going to start right now. I know it's a solid 5 problems. I gave you a hint for number 17, so please take that hint and run with it. Let's get rolling. Only gave you 5.